Good morning, friends. Welcome back to Brain Sizzlers. Today, also, we shall touch upon the topic of work and time, this time in an efficiency perspective. Let us jumpstart with a random example. Let us assume two persons, namely A and B. A can complete a particular work in X days, suppose, and let us assume B is twice as smart as A, or rather, twice as efficient as A. So, now we will try to address two questions. When they join hands together, when will the task be completed, or rather with their combined effort, when will the job be completed? The second question is, if we are freezing the time frame, say for example if both are working for a fixed span of time, say X days, what will be the quantum of work done together? So let us address both of them. First and foremost, efficiency can be looked in two ways. Say, as we have said that B is twice as smart as A, or B is twice as efficient as A. So when we are freezing the work, if A does a particular work in X days, obviously B can do it in half as much time. So B will take obviously X by 2 days. Now if we are freezing the time, if A does a work, one quantum of work in X days, B in the same X days can complete two quantum of work. So A if is completing 1 unit of work, B can complete 2 units of work in the same stipulated time. Now let us address the first question. We already know that the combined time taken by both the persons to do a particular task can be given by the basic formula x into y by x plus y, where x and y are individual time taken by A and B to complete a particular task. Now, having that in mind, here the two values are x and x by 2 respectively. So, applying that in the formula, what we will get is x by 3 days. So, this is nothing but the combined time taken for completing a particular task. Now, the second issue, when we are freezing the time frame, to be x days, the task will be completed, different quantum of task will be completed, namely A will complete 1 unit of work, in the same time frame B will complete 2 units of work. So the cumulative work done by both of them will be 3 units of work. Now let us make a mathematical correlation between the proportionate change of quantum of work of B with respect to A, and then the percentage of work that B does in excess to that of A. So we will frame an equation, and then we will find a correlation. So B can be addressed as 100 plus percentage rise of B with respect to A by 100 into A, and that can be very well written as B equal to K times A, where K refers to the that much times more efficient as that of A. So if in the above example we saw that B was twice as efficient as A, so in this particular case K can assume a value of 2. So comparing these two equations, namely 1 and 2, we can frame a relation between K and percentage. So K can be written as 100 plus rise in percentage of B with respect to A by 100. I am simply writing the percentage rise in efficiency of B with respect to A as percentage RE, just for the sake of better understanding. So percentage RE can be rewritten as 100 times K minus 1. Now we will frame the combined effort time taken expression in terms of the proportionate change of B with respect to A. So we will substitute every values. So x is x as such, B will take x by k days. So the final value that comes out will be x by k plus 1. So x by k plus 1 is the number of days taken for the combined effort. Now if we start to express this in the context of percentage rise of B with respect to A, this equation will assume a different form. So instead of K, when I express it in terms of percentage higher efficiency of B with respect to A, it will be x into x divided by 100 plus percentage RE by 100 whole divided by x plus x divided by 100 plus percentage RE by 100. After simplification, the final result turns out to be 100x by 200 plus percentage RE. 200 plus percentage RE comes in the denominator. Now, this is quite a useful formula when we are in the competitive exams where you can save a lot of time. Let us consider a typical example. If a person A finishes a work in 15 days and if a person B is 40% more efficient than that of A, then when will the task be completed? What is the time frame for the task completion for the combined effort? This is the question being asked. We can straight away use this particular shortcut formula, which is 100x by 200 plus percentage RE, where x refers to the individual time taken by A to complete the task. Now this applying this formula outrightly, so 100 into 15 by 200 plus 40. So 15 is the number of days taken by A, 200 plus 40 is the percentage rise of efficiency of B with respect to A. So cumulatively they will take 6.25 days. When we apply this in the examination arena, it will save quite a lot of time. Thanks a lot for watching. Have a nice day.